Daily Work Unit 3.5. Name the legs. We can name the legs because this is a triangle with at least two equal sides. The two equal sides are called the legs. This leg is FX. You can either call it segment FX or segment XF, and then you could name the other one. The third side is called the base. The vertex angle is the angle included between the legs. And so the vertex angle would be this angle up here. You can name it angle F because it is the vertex of only one angle. And the angles at the base are called the base angles. Okay. Now we're going to answer some questions at the bottom. It says find the missing links or angle measures. The first one, we kind of figure you can handle the first two. You're obviously using the concept that sides opposite equal angles are equal, or angles opposite equal sides are equal. But let's look at number 7. Number 7, if two angles of a triangle are equal, then we know that the sides opposite those equal angles are equal. So those two sides are equal, so we say 3x plus 1 is equal to x plus 13. Now again, with the order of operations horseshoe on page 31 of the algebra text, we would say, is there anything that we can do on either side to simplify? And the answer is no. And then we would move to the bottom of the horseshoe, which says, get the variable that you're isolating on one side of the equal sign, remembering to change the sign when you cross over. And we're going to let you finish that. I just wanted to remind you once again of the bottom of the horseshoe, page 33. Students seem to get stuck on that occasionally, okay? So sides opposite equal angles are equal, and angles opposite equal sides are equal. All right. Let's see if we can answer some of the questions, or at least get started on answering some of the questions here in the next section. We know that if two sides of a triangle are equal, then the angles opposite those equal sides are equal. So if that angle is 60 degrees, and we know that this angle is also 60 degrees, so angle X is 60 degrees. Now, what we have to also recall is the isosceles triangle theorem. Notice what we have is two things, and I'm going to color code it the way I taught it. We've got that this side, remember we made it green in the isosceles triangle theorem lesson, is equal to this side, and this angle is equal to this angle, which means that this is the vertex angle bisector. So we have two things already marked. We have isosceles triangle and vertex angle bisector. And so we can say the isosceles triangle theorem. The bisector of the vertex angle of an isosceles triangle is perpendicular, meaning that that's 90. We did it in black in the lesson. Perpendicular to the base at its midpoint, which means that this is equal to that. So if this is 7, then it's 7 over here. Angle ARM is 90 degrees because it's perpendicular, and it's perpendicular, we know, because of the isosceles triangle theorem. And with that, we can answer a lot of the questions in sections 8 through 13 of questions. Any questions there? Okay. We're going to take a look at number 14. Again, I want to keep going over some proofs with you. because it seems to be something that's a bit difficult for students, and I just want to make sure that we teach you through as many as we can without doing all your work for you. We're hoping that when we do work together in class, you go back and study it on your own, knowing that you have to duplicate that on the test on your own. So remember, we said to write a proof. You write the given proof. You put your statements on the left and your reasons on the right, and you draw the diagram. Some people again say, well, what's the proof? The proof is the statements and reasons. So we write the given proof, put the statements on the left, reasons on the right, draw the diagram. We take what we're given, AB is equal to CB. We mark it in the diagram. We write statements and reasons derived from the markings in the note section. Well, what we marked was AB is equal to BC. And the reason is given. And we think, well, what can we get out of that? What do we get because we know those are equal? Well, since we know those are equal, we can quickly say that angle 2 is equal to angle 3 because angles opposite equal sides are equal. And that's about as far as we go. Given that those are equal, we can automatically say that the angles are equal. Angles opposite equal sides are equal. So we wrote the given proof, put statements on the left, reasons on the right, drew the diagram. We took what we were given, marked it in the diagram, wrote statements and reasons derived from the markings in the notes section. Now, if we were going to do the entire proof, what we would do next is we would make what we're trying to prove the last statement in our proof, and we would try to come up with a reason to prove the proof part. And so we would think of every way we could possibly prove that two angles are equal. Things like vertical angles are equal, alternate interior angles are equal, corresponding angles are equal, definition of an angle bisector, definition of perpendicular, complements of equal angles are equal, supplements of equal angles are equal, of two sides of a triangle are equal, the angles opposite those equal sides are equal. And we could just keep on going. Addition, property of equality, subtraction, property of equality, substitution, property of equality, transitive property, reflexive property. You see all this stuff that goes through your head, you just got to keep thinking about all the things that you've ever learned of how to prove the proof part. Now, if they give you the statements, then you don't have to go through all of that to try to just give the reasons. But we did say we really should go ahead and take what we're given, mark it in the diagram, write statements and reasons derived from the markings in the notes section. And then we're going to give reasons, and when we're giving reasons, we look first in the given, second in the diagram, which includes the notes section, and third, statements above. And so we go to statement 1, and it says AB is equal to CD. So we look first in the given, and it's there, and so we put given. Whoops. We go to the second statement. It says angle 1 is equal to angle 2. We look in the given. It's not there. So we go to the diagram. Angle 1 and angle 2. Here's angle 1. Here's angle 2. It wasn't already marked, but we're going to go ahead and mark it because we can see that they're a special kind of angle. They are vertical. Vertical angles are equal. That's angles across from each other when two lines intersect. And the reason we go to the diagram second is because you may see things like vertical angles are equal. You may see things like angle addition or angle subtraction or segment addition or segment subtraction. Or you may say see things like a linear pair. So there's things like that. Or you may see something that you marked in your notes section, you see. Okay? And so we go to the next statement, and it says angle 2 is equal to angle 3, and we look in the given, and it's not there. So we go to the diagram and we actually see it marked. Angle 2 is equal to angle 3. And if it's marked angle 2 is equal to angle 3, then there should be a reason in our note section for it already. And there is. It says angles opposite equal sides are equal. And I'm going to let you finish that. You're going to get to the next statement, 3 equal 4. You know you look first at the given, second at the diagram, third at the statements above. The fifth one is not going to be given. If what you're trying to prove was given, you wouldn't have a proof. Do not put prove. Prove is not a reason. Prove is the last statement. The reason has to be some definition, postulate, theorem, or property of equality. The last thing that you're trying to make a reason for will always be found in the statements above. Because the whole proof is a set of statements and reasons to justify why you're saying that this is true by that reason. So the proof, the statements and reasons have to lead to somehow final reason. Okay? It may not take all of them, but it's going to take some of them to prove the final reason. Okay? Any questions on that? Okay? Now, here's a proof that you're going to do all by yourself. And let's kind of get you started again on a proof that you're going to be doing all by yourself, which means you're not really doing it all by yourself, I know. But it doesn't already have some statements given, okay? So, to do a proof, we're going to write the given proof proof. The proof is the statements and reasons. To set it up, we put the statements on the left and the reasons on the right and draw the diagram, and we're going to create a note section. So you write the given proof, put the statements on the left, reasons on the right, draw the diagram. We're then going to take what we're given, mark it on the diagram, and write statements and reasons derived from the markings in the note section. So we're going to take this first given statement. We're going to mark what that gives us in the picture. We're going to write down in a note section what we marked in the picture, and we're going to put a reason for that, and it was exactly what it said in the given, so we put given. But we want to think, well, what do I get out of that? Well, what do I get out of knowing that two angles of a triangle are equal is to also know that the sides opposite those equal angles are equal. So I now can say that Rx is equal to RE and justify that with the reason sides opposite equal angles are equal. And I could go even further than that, and I could say this is an isosceles triangle. And I can say that it is isosceles by the definition of isosceles because I just said that two sides of that triangle were equal, and that's the definition of isosceles. So I now know that two sides angles of the triangle are equal, therefore two sides of the triangle are equal, therefore the triangle is isosceles. And now I'm going to take the next given statement, XH equal EH. XH is equal to EH. And I'm going to mark that XH equal EH. And then I'm going to write what I marked in my notes section, XH equal EH, and give a reason. And the reason was given because what I marked was exactly what it said. Now, if those are equal, then that tells me something also. It tells me something about point H. It tells me that point H is the midpoint of segment XE. I can say that because XH is equal to EH, and the definition of a midpoint says that the midpoint of a segment is the point that divides a segment into two equal segments. And so my reason for saying it's a midpoint would be the definition of a midpoint. It is a point that divides a segment into two equal segments. And we're attentive, obviously, to the isosceles triangle theorem because we now see a bunch of stuff that looks a whole lot like the isosceles triangle theorem. What we've done is we took what we were given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the note section. Given something is true, what can you automatically conclude besides that? Well, we wrote those things down that we could automatically conclude. Once you've taken what you're given, marked it in the diagram, wrote statements and reasons derived from the markings in the note section, you're going to write down the prove part. You're going to make it the last statement in your proof. You're going to think of every way that you've ever learned that would prove the thing that the proof says, and you're going to try to use the given diagram and statements above to eliminate as many ways as possible and get down to the way you're going to prove it. So we're down to the point, we've done all of that, and we're saying, okay, we're trying to prove that RH is perpendicular to HE. And this proof is like a roadmap that tries to take me from what they gave me to what I'm trying to prove. And when I get to what I'm trying to prove, I'm done. But to prove that, I have to have a reason for that justified in the statements above it. And so what we have to do is try to figure out what's all the ways that we've ever learned that two things are perpendicular. What's every definition, postulate, and theorem from the first day of school to now that has a conclusion that something's perpendicular? And so we start brainstorming. We start going through the book. Okay, three undefined terms, point, line, plane. And then we had a segment, part of line AB that starts at point A and stops at point B and contains all the points on line AB that lie between point A and point B. And then we got ray AB, and we've got opposite rays, and we've got an angle as a figure formed by two rays, and we got scalene. We've got right angles and acute angles, and we got obtuse angles, and we got a triangle as a figure formed by three segments joining. We're just scanning the book. We've got vertical angles, angles opposite each other, alternate interior angles, same side interior angles, complementary angles, supplementary angles. If two angles of one triangle are equal to two angles of another. But we're not talking about all that. We're talking about perpendicular. So we're saying, okay, we've got to get our mind back on perpendicular. Perpendicular. Perpendicular lines are two lines that intersect to form equal adjacent 90-degree angles. That's the definition. So maybe I could prove that they're perpendicular by definition of perpendicular. Well, how would I do that? Well, I would have to prove that the angles formed by those two lines are equal, adjacent, and 90. Okay? Equal. The adjacent you look with your eyeballs, and the 90. We would have to prove that the angles formed are equal 90-degree angles. And then we could say they're perpendicular by definition of. Then we say, well, I don't know about that. Then we also learned this. We learned about parallel lines. Remember, we said if two lines are parallel and a transversal is perpendicular to one of two parallel lines, then it must be perpendicular to the other. So if I had two parallel lines and I knew the transversal was perpendicular to one, I could say, ooh, because of that, it must be perpendicular to the other. But when you look up here at this diagram, you don't see anything that looks like parallel lines intersected by a transversal, so we can trash that thought pretty good. We're thinking maybe definition of perpendicular, but we got a long ways to go. What else have we ever learned that has perpendicular in it? Well, we learned one more thing, and it's called the isosceles triangle theorem. The isosceles triangle theorem says that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. And we said if you had any two of those things, then you could automatically conclude that the other two are true with the reason isosceles triangle theorem. Ah, that looks like what we've got. That says isosceles triangle theorem. I'm sorry about the weird looking letters that popped out there. Isosceles triangle theorem. Well, it looks like we got the proof done. And we actually do have the proof done, and I was just going to get you started, but I got excited, you see. Now, let's see if we can justify that. If we're going to say isosceles triangle theorem, then we need two out of those four things. Isosceles, it's a midpoint, and therefore we can conclude the other two things, it's perpendicular and it's the bisector vertex angle, and justify that with the reason isosceles triangle theorem. And so we see what statements in our proof are required to say that reason. Those three statements are required to say that reason, and they justify that reason. So that reason is checked off our list, and we go to the next needed reason. Okay? So we're keeping this one, but we're done checking it. So we go to the next needed reason, this one, and see if it's justified and identify which statements are needed to say that. Now, to say definition of a midpoint, we have to have the word, there it is, and then what you get out of it, two equal segments. There's the what you get out of it. So this statement is needed to justify this reason. The statement we were on was needed to justify that reason. The reason for that statement definition of the midpoint is justified. So we're done checking that statement and reason. So we go to the next needed reason. Now we needed this to be able to say midpoint. And it's given, so it's justified. And so that statement was needed. That's a good place for it. And its reason is justified. This reason is needed also to say isosceles triangle theorem. Its reason is definition of a. Take the reason definition of, we have to have the word isosceles, which is here, and the what you get out of it, which is two equal sides. So we need this statement and this statement to be able to say this reason. This reason has statements that justify it. Therefore, we're done with that reason, and we know we are done with the statement that goes with that reason, but that says we need this statement. That statement has the reason angles or sides opposite equal angles are equal. To say sides opposite equal angles are equal, you need the sides are equal, but you need the angles that they were opposite equal also. So to justify this reason, we have to have these two statements. That reason is justified in the statements above it, therefore its statement is done with. So we then need to go to the next needed statement. This statement was needed to make the reason sides opposite equal angles are equal. Its reason is given. Therefore, it's justified. There's no more needed statements and reasons, so we know that our proof must be correct. And so this would be statement 1, reason 1, statement 2, reason 2, statement 3, reason 3, statement 4, reason 4, statement 5, reason 5, definition of a midpoint, statement 6, reason 6, isosceles triangle theorem. And so these two methods of proving it, we said, well, we're not going to use those. We made our choice of the isosceles triangle theorem because it's what the given diagram and the statements in our notes revealed to us that we should use. And so you would take this information from the note section now and stick it over here nicely and neatly without all those scratch marks and check marks into your statements and reasons. Any questions on that? I hope you'll get better and better at proofs as we go. It's obvious you should know by now that to be good at proofs, you have to really be able to quote and understand the definition, postulates, and theorems of this course. The next section is draw and label again, and again I encourage teachers to model these things for their students, and I encourage students to do this because it's going to teach us a lot of things uh, about measuring and building, and it's going to help us also learn the next lesson. The draw and label accurately is just to help us build a mental image on paper of this and hopefully help us later if we're going to construct something in real life activity that we know how to use measuring devices to get that job done. And then that would bring us to lesson 3.6, which we will begin recording later.